Hi there, this is Abhishek, and in this video I will talk about how you can create a bar chart in Shiny, which is pretty much automated in nature, where we want to dynamically update the bar values based on the end user selection. So let's quickly see what output we need from this bar chart. So here is a bar chart, and the title is basically updating bar chart on the fly. So something like I have this different fields which are getting displayed over here, and the objective is based on these numeric fields my bar chart value should be updated, and the values which are present at x-axis is basically the month value, which will remain the same. So if I select solar.r or wind or temperature, my bar values are updating automatically without changes any code or doing it something manually. So that is really helpful in such a scenario where you have 15-20 different variables and you want to have some sort of a simple bar chart or little bit advanced bar chart where you have done all the setting at once, and most of your time is basically going into analysis but not into writing the coding by changing different variables. So in that way it will be really helpful, where you can list down all the variables and keep on changing the bar chart for doing the analysis perspective. So let's go into the backend and see this, how we have achieved it. So first thing is, this is the UI.r file for the user interface. So what we are saying in the title, it's a fluid page, and within that we have the title panel. So title panel is basically specifying the title, which is updating bar chart on the fly, and that's what it is. After the comma, it has the sidebar layout, that means controls on the left side and output on the main screen on the right hand side. And we are saying within the sidebar panel, which is this, we want an input. Input is basically a field. This is the ID which we will access in server.r. So in field is ID, and the text for this select input, which is select a field to create a bar chart, and we want to give choices based on this data set. So the names of the fields of this air quality. So this names function helps us identifying what are the fields within this air quality, and within the air quality we are saying that we need the fields 1 to 4. That means 1, 2, 3, 4 fields to be displayed over here. Why we want to do that? So to understand that, let's go into air quality database or air quality data, which is saying that first, second, third and fourth column are really the numeric one based on which you can create a bar chart, whereas month and day are more of a dimension value, or pretty much kind of a discrete value which will be used for the x-axis. So that's why we don't want these two values, and for that reason we have specified that we just need the variable names 1 to 4. After this, simple a main panel giving you the plot output bar chart, which this bar chart is getting calculated here in the server. So as you see the bar chart mentioned over here in the output is part of your Shiny server function, which helps us populating the bar chart over here in the UI. So within this bar chart we are saying that we need to render the plot. So earlier I have showed you a table example where in case of a table we were saying render table, but here in this case we are saying render plot, and we are doing some calculation over here because for displaying the bar values it should be in a right format. So if you look at the air quality data over here, it's in a flat file, it's in a flattened structure. That means for each value you have the same month value. So for, let's say, month 5, you have, I think, more than 15 or 16 values getting displayed. So if you are doing or populating a bar chart simply by taking month and any of the numeric value, it will show multiple bars for just month 5, but not like this, that one bar for month 5, another bar for 6th month, another bar for 7th month, which helps us aggregating and looking at the data at a high level perspective from a by putting some sort of average or any other function of our interest. So to basically aggregate the data by each month value, we have used this aggregate function where it is specifying by which value we want to aggregate. So here the first parameter is specifying that we want the input from the user for this. That means for which numeric variable we need to display the bar, we are taking it as an input, and air quality is basically your data. Within the bracket, first parameter specify rows, so we want all the rows, and second column specify the column name, so it's basically the column that we need to get, so that's why we are taking dollar input field. And then we are saying by which dimension or by which value we want to show this numeric value. That means this is basically the x-axis, you can understand, and this is the y-axis. This air quality input dollar in field is y-axis. And here I have again specified the air quality database as part of the function, and finally I have specified what is the aggregation type should be, whether it should be sum or it should be mean or any other thing. So for this example, mean makes more sense, so I have specified mean or average. Then we have gone ahead and we have specified the bar plot, and within the bar plot we are saying take the second value from this air underscore agg function, which is nothing but your numeric input field that you have specified over here. So first will be month, second will be numeric field in this aggregate object. So bar plot is basically saying what should be the bar value. Then we have taken the second field from this air underscore agg function, and for x-axis we are saying that we want air underscore agg dollar month value. We could have also specified like this, where we could have said air q underscore agg, and instead of 2 we should have specified 1 to display the month value. But I've just shown you two different ways how you can specify different column values. One way of specifying column values by putting the brackets, another is by putting a dollar sign here in this case. So this is the output we are getting, and its values are getting displayed perfectly fine. If instead of sum we wanted instead of mean we wanted a sum, we could have gone and set sum and try to display, but probably we need to run the application again by first saving it and say run. And in that case you see that values have changed. Earlier the dimension, the y-axis values were around 50, 80 or 100 at the max, but this time it has gone ahead and changed according to that sum aggregation that we have specified. So this is about how we need to mold the data and then finally show it in a Shiny application, but not always you find the data in the similar structure. So air quality, if you see, is in a structure which is a flatten, but sometimes let me use a different structure which is bird.df, and if I hit enter, it's more of a cross tabulate function. So in that case we may need to use a different strategy, because if you see, air quality is a flattened structure, but bird.df is a aggregated or a cross tabulate structure. And in that case we don't have to basically specify the aggregate function because values are already aggregated by our birds. So for that, if I go here in the UIR and the server.r, and within the bird bar plot, we could have simply gone ahead without specifying this. Let me specify it here, that bar plot, and within the bar plot we could have said from the user input we could have taken any of this value, these column values. So for example, let's say bird.df $garden, and for x-axis we need to take these row names. So for that, names.arg function will going to specify the row names and row names of bar.df. So that's how you can quickly say it. In that case, you don't need to aggregate anything. It's already pre-aggregated for you. So the thing is that you really need to have a keen eyes or a good eye on your data format. And if it is a flatten, then you need to use aggregate or some other function based on your requirement to aggregate the data. If it is a cross tabulate, then your work is pretty much simplified. And if you don't want any further modification, you simply go ahead and specify the values over here. So that's pretty much all I wanted to discuss in this video. Maybe as an exercise, what you can do is take these bar.df values from here and modify the Shiny application, the UI.R, to accept these column values here in the choices, and within the server.R take these choices and display the values by each of the bar. Then display your dynamic bar plot by them. So I hope you will be able to run this exercise with all these different pointers I have given you, and I'll meet in a new video with a new topic.